Use the definition to find the derivative of f of x equals 1 over x to the 3 halves, then evaluate f prime of 4. The first thing to do is write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x divided by h. The next thing to do is to formulate f of x plus h. That means to take f of x, 1 over x to the 3 halves, and replace every x with an x plus h in parentheses. 1 over x plus h to the 3 halves. We're going to subtract from this the f of x, 1 over x to the 3 halves, and put it over h. We have the 0 over 0 indeterminate form as h goes to 0. And we will continue to have the 0 over 0 indeterminate form until we can factor an h out of the numerator to cancel with that h in the denominator. That is always the goal of the definition of the derivative. We have no ability to factor an h out of the numerator right now. What we have in the numerator is a difference of fractions. We need to combine those fractions together over a common denominator. We have a denominator of x plus h to the 3 halves and x to the 3 halves. The common denominator will be the two multiplying each other. So my next step is to put each of these over a common denominator. We're going to take the first fraction, 1 over x plus h to the 3 halves, and multiply by x to the 3 halves over x to the 3 halves. And we're going to take the second fraction, 1 over x to the 3 halves, and multiply by x plus h to the 3 halves over x plus h to 3 halves. All of this is over h. So f prime of x will equal the limit as h goes to 0, multiplying the numerators, 1 times x to the 3 halves, minus 1 times x plus h to the 3 halves, all over multiplying the denominators for the common denominator, x to the 3 halves times x plus h to the 3 halves. Since they're both to the same power, they can multiply each other and have the quantity raised to that common power of 3 halves. All of this is divided by h. The next step is to take the denominator, h, reciprocate it, and multiply it with the numerator. So we can take it out of the denominator, put its reciprocal in the numerator as 1 over h. Now we will multiply these, and that will give us limit as h goes to 0 of x to the 3 halves minus x plus h to the 3 halves over h times x plus h, all raised to the 3 halves. We still have 0 over 0. We still have that h in the denominator that needs to cancel with that h in the numerator. The numerator has a 0 because we have a difference of what is 2 square roots, because 3 halves means cube and then square root. And since we have a difference of square roots, that's a root combination. Let's write these as roots to make it a little more apparent. Limit as h goes to 0 of x to the 3 halves means the square root of x cubed. X plus h to the 3 halves means the square root of x plus h cubed. And we'll put it over the denominator. Just as we see it. The numerator is a root combination, a root involving the variable h, which is the limit here, in some way, added or subtracted together with at least one other term. In the case of a root combination, the method is the root conjugate. We're going to multiply by the root conjugate. Now the root conjugate is the same expression but opposite sign between, and that means we will have a plus between them. We'll put this over itself, a form of 1, so we don't change the value, just the look, after we go and multiply by that, root conjugate over itself. This will now give us the limit as h goes to 0 of, in the numerator we have root conjugates. We're going to FOIL that out. First, root of x cubed times root of x cubed is x cubed. Outside, root of x cubed times root of x plus h cubed is going to be the positive root of x cubed times x plus h cubed. The inside, negative root of x plus h cubed times the root of x cubed will be negative root of x cubed times x plus h cubed. And then last, we have the negative root of x plus h cubed times the positive root of x plus h cubed, which will be negative of the x plus h cubed. All of this is over the denominator, which is going to be h times x plus h to the 3/2 times the square root of x cubed, which I will just rewrite as x to the 3/2 because I am not actually FOILing out the denominator, I'm keeping it factored, and then plus x plus h cubed under a square root, which will be an x plus h to the 3/2. Just looks a little nicer writing it that way if we're not going to actually FOIL it out. In the numerator, the outside and inside terms are equal value and opposite sign, and they will cancel. Our next step is to FOIL out the x plus h cubed in the numerator. That will give us limit as h goes to 0 of x cubed minus x plus h times an x plus h times an x plus h. Let's pair two of them off and multiply them. X plus h times x plus h will give us an x squared plus 2hx plus h squared. All of that times the third x plus h, which I have not multiplied through just yet. Over this entire denominator, exactly as we see it. Now our next step is to FOIL out the x plus h times the x squared plus 2hx plus h squared. That's going to be 2 terms times 3 terms. That'll give us 6 terms altogether. Which is done by taking the first term x and multiply it times each of them. Be sure to put this in parentheses. We have to subtract all this, but x times x squared is x cubed. X times a 2hx is a 2hx squared. X times h squared is a plus h squared x. And then the h, distributed through each of them, h times an x squared is an h x squared. H times 2h x is a 2h squared x, and then h times an h squared is an h cubed. All of this is over that same denominator. We're not doing anything with that denominator for now. The only thing that we're going to be doing with the denominator is canceling the h that is in the denominator with an h that will factor out in the numerator. The next step is to distribute the minus sign in the numerator, so we will have x cubed minus x cubed minus 2hx squared minus h squared x minus hx squared minus 2h squared x minus h cubed. All of that is over the entire denominator. Now at this point in the numerator, any terms that do not have an h in them should cancel. I have an x cubed and a negative x cubed. Those can cancel out. The remaining terms all have an h in them, and that h can factor. And that's going to be our next step, is to factor that h out. We'll take one h out of everything. That'll give us a negative 2x squared a negative hx, a negative x squared, a negative 2hx, and a negative h squared. All over that entire denominator, exactly as we see it. The h in the numerator and the denominator can cancel, in which case we no longer have the 0 over 0 indeterminate form. We can now plug a 0 in for the remaining h's, and this will become a negative 2x squared minus an x squared in the numerator. Everything else will be zeros, over an x times an x quantity to the 3 halves, and then an x to the 3 halves plus an x to the 3 halves. So the numerator will be negative 3x squared, and the denominator will be x squared to the 3 halves times 2x to the 3 halves. Now we can combine those by multiplying them, and we have negative 3x squared. We have a 2. We have an x squared to the 3 halves, and we have an x to the 3 halves. That'll be equivalent to x cubed to the 3 halves. X cubed to the 3 halves, you can multiply those exponents. 3 times 3 halves is 9 halves. Well, in the numerator we have x squared, which could also be thought of as 4 halves. And 9 halves minus 4 halves is 5 halves. And so our derivative is negative 3 over 2x to the 5 halves. The only other thing to do is evaluate f prime of 4. That will be negative 3 over 2 times 4 raised to the 5 halves. 5 halves means to take the square root of 4 and then raise it to the 5th power. Or you can raise it to the 5th power and then take the square root, but it's easier to do the square root of 4, which is a 2, and just raise that to the 5th power. 2 raised to the 5th power, 2 times itself, 5 times is a 32. And I have negative 3 over 2 times 32, which is a 64.